Mm. Before the class, I want to take a brief review of what we have learned in the last class. In the last class, we learned about uh, the expression of motion. First, we learned the very important thing, reference frame. And we learned the definitions of scalar and vectors. I hope you keep in mind what is the difference between a scalar and a vector. And then we learned how to write a vector and how to divide a vector into components. By learning dividing vectors into components, we uh, learned the calculation of vectors, like vector addition and vector multiplying. We have two forms of multiply for the vector. The first is dot product, and the second is cross product. For the cross product, we need to decide the direction of the cross product using the right hand rule. And then we learned absoluteness and the relativity of motion. And we introduced the coordinate systems. And then we introduced two kinds of coordinate systems. The first kind is the Cartesian system, and the second is natural coordinate system. In today's class, we will learn physics quantities to describe motion. In this lesson, we will learn position and displacement. In order to describe position of something, we need to introduce the definition of position vector. A position vector, we can say it is a vector and it describes the location of a particle relative to the origin of a coordinate system. With a coordinate system, we can draw the position vector like this. For a point P, it has a coordinate system x, y, z. It has the coordinate. And we also have the variable t to describe the relative position with respect to the time. So we can write the position vector of point P as R. Vector R, it equals O, the vector OP. For a Cartesian system, vector R, the position vector, can be written as X I, vector I, and Y, vector J, and Z, vector K. And the magnitude of the position vector is determined by this equation. We have uh, we have uh, analyzed it in the last class. R the magnitude of vector R equals root x squared and y squared and z squared. Okay, uh, the direction uh, of the position vector can be determined by the three angles of vector r with respect to uh, the xyz axis. Uh, as we can see from the uh, plot, cosine alpha equals the magnitude of x over r, and cosine beta equals y over r. Cosine gamma equals z over r. And from math analysis, we can see cosine alpha squared and cosine beta squared and cosine gamma squared equals 1. And then we have the motion function. In Chinese, 运动方程. We know that the position vector r can be expressed with the variable t as x, t, I, unit vector I, and yt unit vector j, and zt unit vector k. For x, y, and z, they are uh, all determined by the time point t, by the time t. So if we write this equation, the the vector r is determined by the time t. It is called the motion function. And then we have trajectory equation. For the trajectory equation, we have three variables, x, y, and z, and we don't have the variable t. For example, we have this function, x equals 6 cosine 2t, y equals 6 sine 2t. What is this function? Motion function or the trajectory equation? In most cases, the motion function and the trajectory equation can be transformed from each other. There are different forms for the description of motion. Okay, I will give you the answer. In this case, in this example, x equals 6 cosine 2t, y equals 6 sine 2t. The x component and the y component are determined by time t. So it is a motion function. But we can rewrite this as a trajectory equation. I hope you can rewrite it. I hope you can think, what will you do? What is the trajectory equation for this motion? Okay, I will give you 1 minute to type your answer in the chat box. What is the trajectory equation for this motion? X equals 6 cosine 2t, y equals 6 sine 2t. Okay, just now we said there are two forms of functions to describe the motion. The first one is motion function. It describes the position vector with time with the time t. And the second one is the trajectory equation. It describes uh, the it describes the um, trajectory of the point. And we can also say it describes the uh, relationship between x, y, and z for every uh, points on the trajectory. So for this example, we can see x equals 6 cosine 2t, y equals 6 sine 2t. And it describes the x component and y component with respect to time t. So it is a motion function, right? And how to rewrite this function into a trajectory equation? We see that we have this uh, relationship for every time point, cosine t and sine t squared, cosine squared t and sine t squared equals 1, right? So cosine 2t squared and sine 2t squared equals what? It equals 1, 2. It equals 1. So for this example, we have x squared and y squared equals what? 36. And this is the trajectory equation for this motion. And then, as we can see, the trajectory equation for this motion is x squared and y squared equals 36. And we know that we can draw it on this Cartesian coordinate system with a circle. And the circle has a radius of what? 6. I hope every student can understand the transformation from motion function to the trajectory equation. So it will be very easy for you to know the um, remaining classes. Just now we learned the position vector, and with the position vector, we can give you the introduction of displacement vector. For the displacement vector, it describes the change of position, or we can say changing in position. Here we have 2 points, A and B, and the position vector for point A is r1 vector r1, and after delta t we have the point after delta t the point moves from A to B, and we have the position vector for B, R2. And the vector from A to B is called the displacement vector, or we can write it as delta R. So with the vector addition or um, vector addition rules, we have this delta R equals R2 minus R1, and it equals x2 minus uh, x2 minus x1 I and y2 minus y1 j and z2 minus z1 k. The displacement vector extends from the head of the initial point position vector to the head of the later position vector. Here are some notes about displacement. One, the displacement is a vector. The magnitude of vector should be the length of this vector. Here is how to calculate the displacement vector. And the second one is also very important. The displacement vector is different from the path. Here we can see the length of the displacement vector equals AB. And we also have the length of the trajectory from A to B, delta S, it equals the length of this arc AB. And we can clearly say that the length of vector AB does not equal to the path from A to B. Giving 2 points P1 and P2, we can see we only have one displacement vector, but we can have many forms of paths. We can have a path that is curved, a path that is like a snake that is very twisted, and we can also have a very straight path. But we can only have one displacement vector. And we should note that when delta t is very close to 0, we can assume that it moves with a very close very close distance. So when delta t is very close to 0, we can assume that the length of the displacement is equals delta S. And we can also see dr equals ds. And the third one, the displacement is independent on the choice of origin. This rule is very easy for you uh, to know, right? Whether the origin is whether the origin is in this point or that point, if the two given display two given points of the displacement is given, the vector is given, and it does not change with the origin. Okay, here are some key points. Just now we learned the position vector. The position vector is written as R, and we can use R equals RT to describe the motion function. And we can calculate the magnitude of position vector with this equation. And then we learned the displacement. The displacement is expressed with delta R, and it is calculated with two position vectors. And we also learned the path and or the distance traveled. Okay, here we have learned some important terms. Now we will learn how to use what we have learned to solve problems in our daily life. Here is example 1. A radio-controlled model car is moving on a plane or XY plane. The car has X and Y coordinates that, that vary with time according to X equals 2t, Y equals 19 minus 2t squared. And problem 1, find the car's coordinates and time t equals 1s and t equals 2s. Then find the displacement during the car interval. And B, find the path equation of the car. C, when the car is nearest to the origin point of XY plane. Okay, first, I will give you 5 minutes to solve this problem by yourself. I hope uh, every student can type your answer on the chat box so I can know how many of you have learned the calculation of the vectors. Okay, please find a pen and a paper to calculate and write down, type your answer on the chat box. No student have write write down the answer. No one got the answer. Hmm, I don't think this question is quite difficult. Okay, let's see the solutions. As we can say, because we can rewrite. Okay, only one student have got the answer. Okay, the two students got the right answer for question A. Half answer. Okay, let's find the displacement during the time interval. We can rewrite the displacement position vector r as 2ti and 19 minus 2t squared. So endpoint t equals 1. We have r1 equals 2 and 17 and 2.2 10.2 we have 4 11 and by uh, doing the calculation r2 minus r1 we have the displacement during the time interval 2 minus 6. Okay, let's see how many students have got the right answer. Here, this student got the right answer. Very good. And this student. Okay, at least we have two students got the right answer. And problem B, find the path equation of the car. In order to find the path equation, we should do what? We should get over t. So we first of all we should rewrite the rewrite t with x. So we have in order to cancel t, we have t equals x over 2, right? So by putting x over 2 uh, into the second equation, y equals 19 minus 2t squared and t equals x over 2. And then we have y equals 19 minus x squared over 2. And this is a parabola. We can draw the trajectory equation in this plot. And for problem C, when the car is nearest to the nearest to the origin point of xy plane. And this one is a bit difficult for you. And we have written and we have drawn this picture on the plot. We have r equals what x squared and y squared, root x squared and y squared. So if dr dt equals 0, then r equals the minimum r. So we have t equals 3 seconds, r equals 6.08 meters. This is the minimum of r. Okay, then we will let's see. Let's take a 10 minutes break. After 10 minutes, we will continue our class.